Hi guys, Miss Monserrati here. I have the chapter review for chapter 9. Alright, so chapter 9, we're adding and subtracting fractions. So, first part, write each of the following on the lines to make a true sentence. Alright, here's my words. Equivalent fractions, mixed number, least common denominator, unlike fractions, and like fractions. So, I don't know why these two are colored yellow. Fractions that have the same, because they're just words, because they're just words from this chapter that we use, right? Like fractions and unlike fractions. So like fractions are like when I have 1/2 plus 1/2. They're the same, right? Unlike fractions would be when I add 1/2 plus 1/3. Right? I could do 1/8 plus 3/8. That's like fractions. Oops, sorry, I drew a line through it. Unlike fractions would be 1/8 plus 3/9. They're not the same, right? The denominators are not the same. So, all right, fractions that have the same denominator, such as 1/3 and 2/3, are like fractions. They have the same denominator. I call them like fractions. Right? The denominator is the number on the bottom. That was one of from our practice right before, right? The denominator and the numerator. My brain isn't working. It's late again. So what I was trying to say is from our check my progress that we did it before. All right, fractions that have the same value, such as 1/4 and 2/8, are, right, these aren't like fractions, they have different numbers, but they have the same value. 1/4 is the same as 2/8. They are equivalent fractions. They have the same value. Right, like I have my handy dandy fraction pieces, so you can see 1/4 is the same as 2/8. Right, they are equivalent fractions. All right, the blank of 5/6 and 7/12 is 12. Right, I'm looking for the denominator to be 12, the least common denominator. Right, I could turn a 6 into a 24 and a 12 into a 24. I need to find the least, the smallest. So we could do our abbreviation, right? I'll write it out. It's the least. You can do the abbreviation though if you remember it, but it's probably good for you to write it out too to practice your writing and minator. But right, I do abbreviate this. I call it my LCD. All right, we have all kinds of GCF and all those letters, right? A number that has a whole number part and a fraction part is called a mixed number. I should be doing a cursive. An example of 2 blank are 1/8 and 3/4. An example of 2, right, I already used a bunch of these words, so I'm going to say unlike fractions. An example of 2 unlike fractions, it was my only word I had left too. But I know these are unlike fractions, they have different denominators. All right, we're going to round each fraction to either 0, 1/2, or 1. So 4/7. Right, I'm going to see where it is closest to. I know 7, right, doesn't have a half number. I know 3/6 do, but so one thing I would do is find an equivalent fraction for 7. 4/7. I'm going to find an equivalent fraction. I'm going to multiply times 2 and times 2, and now I will have 8/14, right? 7/14 would be half. So I'm going to say 4/7 is going to be very close to 1/2. If it was 9, 10, 11, if I was rounding between 0 and 1, I would round 8/14 to 1. We don't normally round to a half. It's just your book wants, we're trying to practice to make sure you understand this concept, right? How do I know? Right? This would be closer to, but it is closest to 1/2 right here. So I'm going to say this is closest, it's about 1/2. How about 9/10, right? I don't really need to even look at this one. 9 out of 10, it's almost 10 out of 10. It's almost 1. All right, 2/9. Ooh, this is a tricky one, right? I don't have a number that I can divide by 2 here. I could find an equivalent fraction, though. If I multiply times 2, I will have 4/18. Right, half of 18 is 9. I just did that math so you could see, right? 9 would be half of it. So this is closer to 0. 4 is closer to 0 than it is to 9, right? All right. Next problem on the back, we're going to add. Write each one in simplest forms. All right, so ready? This is practice for our math test. So 9, 9, 9, 5, 1, 6. Woo, but it's not in simplest form, right? I know 6 and 9 can both be divided by 3. So I'm going to do that. I'm going to divide by 3, divide by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Final answer is 2/3. All right, we're going to go here. 7, 7, 7. 6 plus 1 is 7. 7 over 7 is equal to 1. All right, I'm going to add here 8. Right, 8, 8, 8. 5 plus 1 is 6. But hopefully you can see both of these can be divided by 2. So now 6 divided by 2 is 3. 8 divided by 2 is 4. My final answer is 3/4. Here we got to do some changing around. I cannot add these, right? I need to find a common denominator. I'm going to make my common denominator 10. So this is already a 10. I'm good there. I need to turn this one into a 10. So I'm going to multiply times 2 times 2. So 2 times 3 is 6. And 2 times 5 is 10. Now I can add 10, 10, 10. 6 plus 1 is 7. All right, same thing. I can't add an 8 and a 2 fractions. I can turn this 2 into an 8, though. I'm going to do that by multiplying times 4. Whatever I do to the bottom, I have to do to the top. So I'm going to have 4/8. Now I can add 8, 8, 8, and the 4 plus the 1 is 5/8. All right, my 7 and my 14, can't do it, but I know when I add them together, I'm going to have a 14 here. So I'm going to turn this 7 into a 14 by multiplying it times 2. Whatever I do to the bottom, I have to do to the top. So now this is going to turn into 4/14. Now I can add 14, 14, 14. 4 plus 5 is 9. All right, now we got some mixed ones over here, right? When I'm subtracting, I don't need to borrow, but I will need to probably reduce it and rearrange it when I'm finished. All right, so here we go. 6 3/4 plus 2 2/4. So I'm going to say 6 plus 2 is 8. I'm going to have 4, 4, 4. But over here, I'm going to have 3 plus 2 is 5, right? And your brain, we can't have a bigger number on the top than on the bottom. So I'm going to change my 5/4, right? There's different ways to do it. I can divide. If you think this is easier, just do that. 4 divided by 5, 5 divided by 4. 4 goes into 5 one time. 1 times 4 is 4. I subtract, I have 1. My remainder goes on the numerator, is the new numerator for my fraction remainder, and I have 1 1/4. So now I can add this 8, because now 5/4, right, is equal to 1 1/4. The other way I can figure this out, I'm going to just do it on this problem, is 5/4. Somehow I feel like this would be easier for you guys, but I'm not sure which way you'd rather do it. I know I have a 4/4 in there. I'm going to take it out. Right, now I can figure out, I know if I'm doing backwards, right, I know my answer and I want to figure out how many fourths would I need to add to 4/4 to get 5/4. I need 1 more fourth. So now I know I have 4 1/4, right? That's the same thing. I have 4/4 and 1/4, which 4/4 is equal to 1 1/4. Hopefully I made sense there. So now my fraction, I need to fix it, right? Now I'm going to add this 1 to my 8, which is going to give me 9, and then I can't forget my 1/4. My final answer, 9 and 1/4. All right, so I'm going to add over here. 1 plus 3 is 4. I'm going to add I had 12, 12, so I didn't need to do anything. 12, 12, 2 plus 1 is 3. But hopefully you can see here, 3 and 12 are both divisible by 3. So I'm going to divide by 3 on the top, divide by 3 on the bottom. My 4 is going to stay the same. I should have written it first. 4, and now I have my fraction. 12 divided by 3 is 4. 3 divided by 3 is 1. My final answer is 4 and 1/4. So sorry, I know I'm going fast. So you guys might have to pause it. Hopefully I'm not talking too fast. All right, I need to add my 6's here, right? I need to add my numerator. I can't do my denominator. I can't add this denominator when I have a 6 and a 3. I'm going to change this 3 into a 6 by multiplying it times 2 times 2. So now I have 2 times 1 is 2 over 2 times 3 is 6. Now I can add. I'm going to take my whole numbers, my 12 plus my 6, and get 18. And I'll have my fraction here is going to be 666. I'm going to add my numerators. 2 plus 2 is 4. But I can't leave it like that, right? I have to reduce it. So it will still have my 18 the same. But this 4/6 I can divide by 2, divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. My final answer is 18 and 2/3. All right. I am going to skip the estimating part. I should though, but I'm going to skip. I could tell this is like almost going to have 0, take away 0 though, but all right, let's do. We're going to subtract here. I know 16, 16, 16. I'm good there. 7 take away 3 is 4. Hopefully you can see both of these numbers are divisible by 4, right? 4 divides by 4 and 16 divides by 4. So I can reduce this. 4 divided by 4 is 1. 16 divided by 4 is 4, because 4 times 4 is 16. My final answer is 1/4. Next problem. Oop, nice, I can do 12, 12, 12. 11 take away 7. Sorry, 11 take away 7 is 4. Right, 4 plus 7 is 11. And now I'm going to divide. I'm going to find an equivalent fraction that's simpler than this one. I'm going to divide by 4, divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. My final answer is 1/3. One last number 20 here. 5, 5, 5. 4 take away 2 is 2. Final answer, 2/5. All right, over here, 9 and 6, right? I have to find a common denominator between 9 and 6. One way I could do it is just take my 9 times my 6 and make my common denominator 54, but that's going to be kind of big, and hopefully you guys can see. I know 2 9s is 18 and 3 6s is 18, so I'm going to change both of these to 18. I'm going to write my math down here below. I feel like that will be easier. I'm going to take 18 and 18. Right, to turn my 9 into an 18, I multiplied it times 2. And to turn my 6 into a 18, I multiplied it times 3. Hopefully I said 18 both times. All right, 2 times 9 is 18, and 2 times 8, right? I have to do the same thing I do to the bottom to the top. Is going to be 16 18ths. And here I multiplied the bottom times 3, so I have to multiply the top times 3. 3 times 6 was 18. 3 times 5 is 15. Now I can subtract. I'm going to have my 18, 18, 18. 16 take away 5, 15. 16 take away 15 is 1. 16 take away 15 is 1. All right, my next problem. So 12 and 8, right? If I multiplied them together, I could do that, but I'm going to get a very big number. So I'm going to see, is there any other way? How about 24, right? I could see both of these numbers could turn into 24. if you know your math facts, I'm going to subtract. I'm just going to move my problem here doing my math. To turn my 12 into a 24, I multiplied it times 2. To turn my 8 into a 24, I multiply it times 3. Whatever I do to the bottom, I have to do to the top. So I turned my bottom into 24, and I have to turn my top into 22 because I take 2 times 11. Here I did 3 times 8 on the bottom, so I have to do 3 times 7 on the top is going to be 21. Now I can subtract. Denominator 24, 24, 24. Subtract 22, take away 21 is 1. Alright, one more problem over here. I take away fifths from tenths. I cannot do. I'm going to turn my fifths into a 10. I'm going to multiply it times 2 to do that. So whatever I do to the bottom, I have to do to the top. So now I'm going to have 2 tenths. So I'm going to put another equal sign. 7 take away 2 is 5. 10, 10, 10. I have 5 tenths. Hopefully you could see that both of these numbers are divisible by 5. So I'm going to write it in simpler terms. 5 divided by 5 is 1. 10 divided by 5 is 2. Final answer is 1/2. Sorry, just pause it. I know I'm going so fast. Russ is putting his vacation photographs in an album that is 12 1/8 inches long and 10 1/4 inches wide. Should he trim the edges of the photographs to 12 inches long and 10 inches wide, or 12 1/2 inches long and 10 1/2 inches wide? Alright, sorry, I had to go read this by myself for a minute. So, 12 and his photo album, right, is this big. 12 1/8. Oh, and 10 1/4. It probably goes this way though, because it said wide. Normally I do wide as this one, wide, and this is long, but alright, so we're just picturing his photo albums. So he wants to cut these thick pictures to put them on here. If he cuts them 12 1/2 by 10 1/2, they're going to be too big, right? 12 1/2 is bigger than 12 1/8, and 10 1/2 is bigger than 10 1/4. Right? A half is bigger than 1/4. And an eighth, right, his picture frame only is, and it's 1/2. So I could see 1/4 is bigger than 1/8. No, it's not going to work. So he's going to need to cut his pictures to 12 by 10 inches. So let's say we're going to I'll just write 12. Ooh, let's do the abbreviation for inches. Do you guys know how to do it really super easy? I put 2 apostrophes. 12 inches times 10 inches. That's how big he should cut his pictures. I should have probably put long. Oops, I put my carrot upside down. Long and wide. Alright, Steve watched television for 3/4 of an hour on Monday and 5/6 hours on Tuesday. How much longer did he watch television on Tuesday than on Monday? So they're already telling me, right, this is bigger than this. It's hard to tell because I have unlike denominators there. I have unlike fractions, so it's hard to compare them. But they're already telling me how much longer did he watch television on Tuesday than Monday. So we're going to take Tuesday first because he watched it longer on Tuesday, and I'm going to subtract how long he watched on Monday. Right, hopefully you guys could already see 6 and 4 both turn into 12. They also both turn into 24. I'm going to take this one times 2, and I'm going to take this one times 3. Alright, so 2 times 6 is 12. Whatever I do to the bottom, I have to do to the top. 2 times 5 is 10. Now I'm going to subtract. 3 times 4 is 12. Whatever I do to the bottom, I have to do to the top. 3 times 3 is 9. Now I can subtract. 12, 12, 12. 10 take away 9 is 1. So 1/12 of an hour longer. Not very long. When Ricky walks to school on the sidewalk, she walks 7/10 of a mile. She then takes a shortcut across the field, which is 1/4 mile long. How long is Ricky's route to school? So it's right, she's taking a shortcut, and you're like, it's going to take her less time, right? So when she takes the shortcut, it is only 1/4 of a mile long. How long is Ricky's route to school? I thought she was taking the shortcut. But no, she's going to walk to school on the sidewalk, and then she's going to cut across the field to get the rest of the way. So I need to add these two numbers together. 7/10 plus, I had to read it again to see what she's doing. She then, so she walks on the sidewalk, and then she takes the shortcut. And then she goes 1/4 of a mile more. So I'm going to add these together, right? I have an unlike denominator here. But hopefully you guys can see, I can change a 10 into a 20 and a 4 into a 20. Right? I could also make them into 40 and reduce it afterwards. But let's just turn them into 20. I multiply 2 times 10 will give me 20. And 5 times 4 will give me 20. And then I'll be able to add, right? 20, 20, 20. All right, so whatever I do to the bottom, I have to do to the top. Oops, 2 times 10, 7. So I'm going to have 2 times 7 is 14. Plus, whatever I do to the bottom, I have to do to the top. So 5 times 1. So I'm going to have 14 plus the 5 is going to be equal to 19/20. She almost walked 1 whole mile to school, but not quite a mile. All right, my last problem on this page. PETA was swimming with stingrays. The first stingray she swam with was 5 1/4 feet long. The second one she swam with was 4 3/4 feet long. How much longer was the first stingray? So here I know I'm going to subtract. How much longer? So one was longer, the 5 1/4. I'm going to take away 4 3/4. Right, hopefully you see here, I can't do that. I can't take away 3 from 1. But I can borrow from this 5, right? And 5 is going to be the same as 4 4/4. So I'm going to put my 4 there, and I'm going to add this 4/4 to my 1/4, and now I will have 5/4. Now I can subtract. 4 take away 4 is nothing. 5/4 take away 3/4. I'm going to have 4, 4, 4, and 5 take away 3 is 2. Right, and can I leave this like this? No, no, say no. We have to divide by 2, divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. I have a 1/2 a foot for PETA's swimming with stingrays. Or which one's bigger? It is 1/2 a foot bigger than the other stingray. Finally, last but not least, alright, I usually skip this because we don't have time, but I'm recording it, so I have all day long or night. Alright, how can equivalent fractions help me add and subtract fractions? Right, this is called a graphic organizer. It's just a way I can organize my information. So, we're going to use what we learned about fraction operations to complete my graphic organizer. First, we're going to write an example. How can equivalent fractions help me add and subtract fractions? So here, we're going to have, how can equivalent fractions, right, I'll have 1/4 plus 1/3. I probably should have done a different one. I need to do equivalent fractions, right? I'm going to change my 1/4 and my 1/3 into equivalent fractions that I can add together. So my 4 is going to turn into a 12, and my 3 is going to turn into a 12. I multiply times 3, I multiply times 4. Whatever I do to the bottom, I have to do to the top. So instead of 1/4, I'm going to have 3/12. Instead of 1/3, I'm going to have 4/12. And now I can add. And now it says to use a real world example. So I'm going to use 1/4 and 1/3. I'm going to say Joe ate 1/3 of the cookies. Sue ate 1/4 of the cookies. How many cookies did they eat? Period. Right, now I would just do 3/12 plus 4/12. They ate 7/12 of the cookies. I'd probably have to write of the cookies. All right, here's my estimating 1/4 plus 1/3. I'm going to say 1/4 plus 1/3. We're going to estimate it. Right, 1/4 is less than 1/2. 1/3 is also less than 1/2, right? 2 6s would be 1/3 if I'm turned it into 6s. Sorry, and 3 6s would be a half, so I know this is less, right? So sorry, I would probably turn this one into 8s. I'd say 2 8s, or actually I could just leave it at 4ths. 2/4 would be half, and this is only 1/4. So this is less than 0, or less than half, so I'm going to round it to 0. 0 take away 0 is 0. Sorry, is almost 0. It's about 0. That's how I would estimate, right? I'd say 0 take away 0 equals 0. My vocabulary for this chapter that's why those words were highlighted in yellow. My vocabulary is like fractions and unlike fractions. So I'm going to say like fractions and unlike fractions. Hopefully this helps to make it a little clearer for you. If not, don't worry, because I know these are kind of confusing. Now reflect on the central question. Write your answer below. How can equivalent fractions help me add and subtract fractions? And I'm going to do, I think we did this somewhere else too. Equivalent fractions let me find common denominators let's do a good work. To perform subtraction or addition operations. Right, if I want to do addition or subtraction, I need to find an equivalent fraction so that my denominators are alike so I can do my math.